How's it going, everybody? Mr. Biles here. Okay, so what we're going to be doing today is solving equations by using identities. This is the example that we went over yesterday. Okay, and this is one in which we remember we can write everything in terms of sine and cosine because we don't have an identity with tangent and sine just straight up like one equals the other. So what I'm going to do is I'm going to rewrite tangent as sine of x over cosine of x plus sine of x equals 0. I'm going to move the sine over to the other side of the equation. And remember, negative sine of x is the same as negative sine of x over 1. What I can do now is cross multiply equals negative sine of x cosine of x. I can't divide by a trig function. That would eliminate solutions. So what I have to do is move this one over to the other side. We've seen equations like this before. I'm going to factor out sine of x, divide each of these terms by sine of x, and now I set each of my equations equal to 0. Sine of x equals 0, that's my y values. So where does that happen? It happens here and happens here. So this generates two solutions, 0 and pi. This one, cosine of x equals -1. That's going to happen here at pi. So therefore, our two solutions would be 0 and pi. You don't write pi twice, even though it comes up on this one. This one's the same solution. Now, because we have tangent in our original equation, sometimes tangent is undefined. So what we have to do is check our equation, or check our solutions with tangent. Now, sine can be, it's never undefined, so it can have any value with sine. But with tangent, we have to check 0 and pi to make sure we don't get undefined. So tangent of 0, remember it's sine over cosine, so that'd be 0 over 1, which is 0, so that works out okay. And tangent of pi would be 0 over -1, because it's sine over cosine. That's going to be 0 as well, so those both work out. So therefore, 0 and pi are valid solutions. Let's look at this one, okay? We have cosine, we have secant. We don't really have anything that I can substitute in for either of these. So what I'm going to do is rewrite everything in terms of cosine, sine and cosine. Well, therefore, it's going to be this. Now, what we can do here is multiply everything by cosine of x. I'm going to multiply everything by cosine of x, okay? And what I get on this first term is 2 cosine squared of x, then plus cosine of x. And when I multiply 1 over cosine of x times cosine of x, those cancel out, and I end up with 1. I'm going to bring this over here to this side. And now I'm going to factor this, because we have a quadratic trinomial. 2 cosine of x, cosine of x. And some of y'all, if y'all let a equaling cosine of x, it'd be 2a squared plus a minus 1 that you'd factor. But I'm just going to jump into cosine. It's going to be 1 and 1 here. And this would have to be a positive. You double check that. You see that these indeed work. Okay. So now I set, and this equals 0. I set each of these equal to 0. Now I'm going to go ahead and move up here so I have more room. 2 cosine of x minus 1 equals 0. So I solve that, I end up with cosine of x equals 1/2. Cosine of x equals 1/2. That's going to happen here in the first and fourth quadrants. This is where cosine's positive. Cosine's adjacent over hypotenuse. So adjacent hypotenuse, that means that's root 3. That means our reference angle is 60. So our answers are pi over 3 and 5 pi over 3. Okay, and then we have our other one, cosine of x plus 1 equals 0. We just did one exactly like this. Cosine of x equals -1. And so therefore, that would happen at pi. Okay, that would happen at pi. So therefore, our three solutions are pi over 3, 5 pi over 3, and pi. Now, we have secant in here. So this has to be checked. However, the only times that secant would be undefined would be at quadrantals. So that's one good thing. I didn't bring that up last time. I said we have to check all our solutions. But one good thing is you don't have to check at pi over 3 and 5 pi over 3. The only one we have to check for is a quadrantal. That's the only time secant could possibly be undefined. So we have to check secant of pi. And cosine of pi is -1. So secant's -1, just reciprocal that, so that works. So all three of these are valid solutions. So remember, if you have tangent, cotangent, secant, or cosecant in your original equation, and one of your answers is quadrantal, you have to check that quadrantal answer against that because sometimes it's undefined. Alrighty, so let's look at this one. So this one, once again, I'm going to change to sine and cosine. That's 2 over cosine of x. So once again, I'm going to multiply everything by cosine on both sides. Multiply every term by, by cosine. It should be on this side, actually, it's this one. These cancel out, so I end up with 2 sine of x equals cosine times cosine is going to be cosine squared of x. And then these cancel out plus 2. Now, I have sine and cosine. Remember, cosine squared of x equals 1 minus sine squared of x. So I'm going to replace this with 1 minus sine squared of x. Then I'm going to move everything over here. So I get sine squared of x. And this actually becomes 3. So plus 2 sine of x. And 2 plus 1 becomes 3. So that goes over there. So minus 3 equals 0. Now I can factor this, sine of x and sine of x. And I get 3 and 1. It's going to be a plus here and a minus here. Okay. I set each of these equal to 0. All right, sine of x equals 1. Where does that happen? That happens here because our y value. So this generates a solution of pi over 2. This one, sine of x equals -3. That's less than -1, so that generates no solution. So our only possible answer is pi over 2. Once again, because we have tangent and secant, and pi over 2 is a quadrantal, we have to check each of these against pi over 2. So the tangent of pi, that's because we switched this to sine and cosine. The tangent of pi over 2, remember it's sine over cosine, it's 1 over 0, which is undefined, so that is an extraneous solution that does not work. So once that was our only solution, since pi over 2 doesn't work, there is no solution. There is no solution. Okay. And this last one, I'm just going to set this up for y'all. Remember, secant squared equals 1 plus tangent squared. So I'm just going to replace that with that. Bring this over here, and you end up with tangent squared of x equals 1. Take the square root. Tangent of x equals plus or minus 1. That means it's going to be the same reference angle in all 4 quadrants. Because we use special right triangles, it's opposite over adjacent, hence 1, 1. That means our answers are multiples of pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so see what you can do on the worksheet, and I'll talk to y'all later.